Welcome to Cadence Design Systems Fidelity Tutorial Tuesday, where we show you how to use our fully integrated environment Fidelity in short videos of a few minutes. Today, we'll discuss how to perform a finite element modal analysis for eigenfrequencies and eigenmodes for fluid structure interaction simulations. Starting from the geometry context of the Fidelity DBS template, I have imported our target test case, the NASA Rotor 67 geometry. This is the first rotor of a two-stage fan with 22 blades and nominal rotation speed of approximately 16,000 RPM. In the domain context, the solid domain is created using the whole geometry. The only task here is to locate the seed point inside the domain. This will indicate where the mesh will be generated. The mesh generation in the mesh context is performed using the surface-to-volume approach, also known as S2V, leading to approximately 400,000 cells generated in 5 minutes and 54 seconds on 4 processors. In the simulation context, we create a new simulation using the Oofelie Solver. For simulation 1, we select the modal analysis type in the Config tab. Next, we set the number of modes to 10 in the Control tab. The number of mode shapes can also be input using an upper frequency of interest in Hertz. In addition, pre-stressed modal analysis can be performed using an initial displacement field coming from a static mechanical analysis. At the domain level, the domain type is set to solid, and the material is set to titanium in the drop-down menu. Finally, we set the constraints for this blade with the hub boundary fixed for translation and rotation degrees of freedom. We make sure to activate the Export Mode Shapes option to obtain a preformatted modal data structure file to use in a future FSI computation. The simulation is launched on 4 processors and is completed in less than a minute, and the natural frequencies are displayed in the log viewer. Switching to the results analysis context, a color contour of the deformation field of each mode shape is animated with the time reconstruction mode using the time controller. Note how the blade deformation becomes more complex as we go higher in eigenfrequency. Thank you for watching. If you like this video, be sure to click the thumbs up button to subscribe to our channel for more upcoming content like this. If you have any questions or suggestions for future videos, please drop us a line down below or connect with us on LinkedIn, which is linked in the description. Thank you all and have a great Tuesday.